The policy plane is a feature that makes Cisco SDA pretty unique in the industry. But don't trust me, trust SEC. By the end of our time here together, we will be able to describe how the SDA policy plane operates via Cisco TrustSec. Cisco TrustSec has been around for a little while now. It was designed to help us wrap our arms around the security policy that we need to deploy throughout the entire network. Well, as you can imagine, we need that functionality within an SDA environment as well, which is why it has found another home in the SDA policy plane. We have two network segmentation problems that we need to solve. First of all, a big buzzword in the industry today is microsegmentation. That is a fancy and extremely long word for saying that if I have two hosts in a network, what if I don't want those two hosts to be able to talk to each other? Even if they're on the same subnet, what if one is .2 on the subnet, one is .4, and I need to stop them from talking to each other? And of course, this would apply to inter-subnet conversations as well. And so ultimately what we need to do is scale out our ability to deploy access lists. Because today in a traditional network, that is our method for dealing with this situation. I would deploy an access list onto an SVI or switch virtual interface, and I would block this source IP address from speaking to this destination IP. But that doesn't scale particularly well if I have thousands of devices in my network and I need to really manage who can talk to whom. The other problem we need to resolve is macro segmentation. I know, another mouthful for us, right? So in service provider networks, we need to worry about the fact that we might have multiple customers on the same network. So for example, in this scenario, I might have additional hosts hanging off of the same switch that belong to a different organization. So maybe these belong to organization A, and down here, these belong to organization B. Well, in this scenario, we don't want those hosts to be able to talk to each other at all. And so in traditional networking, we would resolve this with VRFs, virtual routing and forwarding instances. We mentioned this in the SD-WAN conversation. We're going to cover it in more detail later on in the Encore playlist. So back to software-defined access. We need a way to enforce both micro-segmentation policies and macro-segmentation policies. And as such, we're going to introduce two new concepts into this network. For micro-segmentation, we're going to introduce the concept of scalable groups, or SGs. And for macro-segmentation, we're going to introduce the concept of virtual networks, or VNs. We'll start with SGs. A scalable group is designed to cover what we have down here in green. We want to be able to say that certain hosts shouldn't be able to talk to certain hosts inside the same network. And that last part is key. It's within the same network. So within organization B, for example, we would deploy microsegmentation policies. Virtual networks, on the other hand, are for when we zoom out and we take a look at the organizational level. And so we say that this organization can't talk to this organization. So we're going to use virtual networks in order to stop organizations from talking to each other, and we'll use scalable groups to stop certain hosts from talking to one another. Now these policies are probably pretty easy relatively to deploy onto a single switch, but what about this fabric? Because we're going to have other hosts out on the fabric, and we need to enforce these policies regardless of where these hosts live. Well, in order for that to happen, we need to make sure that these policies are able to be carried through the network and respected on both sides. So in order to accomplish that, we're going to introduce two new identifiers, which we already mentioned as part of the VXLAN conversation. One of which is going to be this VXLAN VNID, Virtual Network Identifier. We are going to carry a virtual network within a single VNID. So this VNID really identifies the virtual network for us as it traverses the network. Now in the original VXLAN spec, this was the only identifier that we had within the header. However, remember that VXLAN was expanded by Cisco in order to carry group policy options, or GPO. And so that group policy concept is a new tag, and we call it the Scalable Group Tag, or SGT. Now funny enough, Cisco TrustSec started out with this concept of SGTs, except the S stood for security. There were security group tags in the Cisco TrustSec solution. However, since we can deploy a lot more policy to these other than security, Cisco rebranded the S to mean scalable. And that brings it back in alignment with the terminology that we're using for the group, which is a scalable group. So let's bring this all together. When a packet arrives on a switch, that switch is going to check its policy and it's going to assign that particular packet into a virtual network and into a scalable group. And then it's time to encapsulate that packet and send it across the network. Well, when it encapsulates it, it's going to map the virtual network to a VNID, and it's going to map the scalable group to an SGT. With that data safely encapsulated within the VXLAN headers, we can now send that packet through the network and allow the switch on the other side to receive it and interpret the virtual network and scalable groups from the packet header information. So it de-encapsulates that packet and looks to see, hey, where are you going? Are you going to maybe this host? Are you going to this host? So then it'll check its policy. Can that particular virtual network talk to this host? Do we allow that traffic or deny it? Because if it's trying to go from one VRF to another VRF, we want to deny that traffic. Well, the same thing with the scalable group. What if .4 isn't allowed to talk to .5 that's over here? Or maybe it's a different subnet entirely. Either way, we can look at the scalable group policy. We're either going to allow that traffic or we're going to deny it. Now, it is important to realize as part of a software-defined access infrastructure that we are tagging this traffic on ingress. That means we tag it when the packet arrives on the switch. However, we enforce that policy on egress, which means that the traffic will traverse the network and arrive on the other side regardless of whether that traffic is going to be allowed or denied. So in a lot of cases, we like to enforce our security as close to the source as possible, but in SDA, we do need to transfer it through the network in order to see what the group policy is on the other side. So where does all this policy get defined? Well, you guessed it, in DNA Center. And DNA Center will pass that information to ICE in order to enforce it. So in the end, the policy plane for software-defined access gives us a simplified means of deploying policy, like security policy, into our environment. And with that, you're able to describe how the SDA policy plane operates via Cisco TrustSec. I hope this has been informative for you, and I'd like to thank you for viewing.